In the last lecture, we've seen how to destroy an Ethernet switch using a DOS attack called MAC flooding. In this lecture, I'll show you what countermeasures you can take to protect your network. The first thing I want to tell you is that you can avoid this attack only if your switch has some built-in security features in its operating system and allows a basic management. If you have a home user transparent switch that can only be turned on and off, there is no way to protect it against MAC flooding. Fortunately, all vendors that produce professional devices have included in their switches some security features against this type of attack. For this lab, we have this Cisco Catalyst switch. The countermeasures for MAC flooding is to configure a security feature called port security on the switch. This will limit the number of MAC addresses the switch can learn on each interface or port. A MAC address configured by port security is called a secure MAC address, and there are three types of secure MAC addresses: static secure MAC addresses, dynamic secure MAC addresses, and sticky secure MAC addresses. Static secure MAC addresses are manually configured MAC addresses that are stored in the MAC address table and added to the switch running configuration and saved after a restart. The second category, dynamic secure MAC addresses, are dynamically learned MAC addresses stored only in the address table and removed when the switch restarts. And sticky secure MAC addresses are dynamically learned or manually configured, stored in the address table, and added to the running configuration, so they are also available after the switch restarts. If these addresses are saved in the configuration file, the interface does not need to dynamically learn them again when the switch restarts. Perfect. When the maximum number of secure MAC addresses have been reached, a security violation occurs. The switch can react to a security violation in three different ways: protect, restrict, and shut down. Let's see what does protect mean. When the number of secure MAC addresses reaches the limit allowed on the port, packets with unknown source addresses are dropped until you remove a sufficient number of secure MAC addresses or increase the number of maximum allowed addresses. There is no notification that a security violation has occurred. Then, restrict is the same as protect, just that a notification of type SNMP trap is sent, a syslog message is logged, and the violation counter increments. And the last security violation is shut down, which is also the default mode. In this mode, a port security violation causes the interface to immediately become error disabled. It also sends an SNMP trap, logs a syslog message, and increments the violation counter. When a secure port is in the error disabled state, one way you can use to bring it out of it is to manually re-enable the port by entering the shutdown and no shutdown interface configuration commands. I'll attach a comprehensive resource on port security to this lecture. Let's return to the switch and enable port security for the interface to which the attacker is connected. Let's see the switch interfaces. Show IP interface brief. The interface to which the Linux machine is connected is Fast Ethernet 0/1. We notice that's the only interface enabled. I am entering the interface configuration mode. Conf T interface Fast Ethernet 0/1. Port security works only on an access port, so I set it as an access port. Switch port, mode, access. And I am enabling port security on the port. Switch port, port security. And I'll set the maximum number of secure MAC addresses for the interface to 5. Switch port, port security, maximum 5. And I want the interface to become error disabled when a violation occurs. This is, by the way, the default. Switch port, port security, violation, and we have protect, restrict, and shutdown. Let's launch the MAC flooding attack again. I'm going to Kali Linux and I'm executing the last command. Let's return to the switch. And we notice that the switch has immediately shut down the interface fast Ethernet 0/1. Port security violation error, putting FA 0/1 in error disable state. The security violation has occurred after 5 frames with random source MAC addresses have been sent to the switch. The attack is running, but the switch is not affected anymore. Let's see the MAC address table and CPU utilization. From privileged exec mode, I'll execute show MAC address table. And there is no dynamic MAC learned by the switch. The interface to which the attacker is connected was shut down. Let's see the CPU utilization. And we notice that the switch CPU is idle. The CPU utilization is only 5%. Show interface F0/1 shows us that the interface is in error disable state. Now I know that the attack was launched on port F0/1. If I want to enable the port, I can do it manually like this. I'm going into interface configuration mode and I'll execute 2 commands, shutdown and no shutdown. But first I'll stop the attack, otherwise port security will shut down the port again. So shut and no shut. And the interface changed state to up. Okay, another way to protect against a MAC flooding attack is to implement IEEE 802.1x authentication. This allows packet filtering rules issued by a centralized AAA server such as a Radius server based on dynamic learning of clients. Congratulations, you've just learned how to protect your switches against MAC flooding attacks.